All right, so this is number 5 on 8788 worksheet. And I've graphed this blue line here is y equals 1, the y equals 0 is this blue line, the y equals x cubed is this cubic right here, and the y-axis is the red, so this is the part that's between all of those parts. And I'll show you. Now here's the key thing it says. This says perpendicular to the y-axis. That means your rectangles, let's see, yeah, I'll just use red. That means your rectangles have to come this way. This is my rectangles, which tells me this is the D whatever I'm doing. Is this side over here going like y values or x values? This little part of the rectangle. Y values. This means this is going to be a dy problem because the little rectangle part's going up. And I maybe should not have done that, but I'm doing it anyway, so this thing means dy. What that tells me is what? What does that tell me about every single function on this problem when I'm going to get this volume? Anybody tell me? Everything's going to be what? In y. So you see this thing right here? I got to solve this thing for x. So I'm going to take x cubed equals y. And how do you get rid of a cube? Raise it to the 1/3 power, and you're going to raise this to the 1/3 power. So x, because these cancel out, they reduce to 1, equals y to the 1/3 power, or if you want, you can change it into a radical and put the cube root of y. Either one of those is fine, but it's got to be in terms of y. I'm going to do 1/3 because I'm going to do integration here. Now, when you're doing dy, what's the root? Well, first of all, let's talk about what we are making here. We are making what objects? Squares. So you need to know that the area of a square is equal to side squared. S squared. We all know that, right? All right, I'm going to pull up my Canvas page here real quick, because if you haven't seen this, this is kind of freaky. So I want to show you what these things look like. Real quick, he said. Okay, so on my Canvas page, you see that says pictures of cross sections right here? I'm going to click that, and that's coming up on my other screen. So let me get this back out of the way. Let me bring this one over. I got some pictures off the internet of cross sections. Now, the one on the upper right doesn't show very well. Like this is rectangles. So the shaded yellow part is this bottom part, and the rectangles are coming off the bottom. Triangles coming up. Here's more triangles coming up. Let's go down here further because I think I got squares. So if you look here, the yellow one's triangles, the purple one over here, these are squares coming off the page at you. The blue one's rectangles, these are semicircles. So on this problem we're doing right now, that red rectangle, that is the bottom of the square. And if you could picture this right here, this square is literally coming off the screen at you. And it's coming off the screen at you the same length as it is from the green over to the red y-axis. That's the base, that's the bottom of the square. It's coming at you the same distance, coming across, going back down, making squares. And it's making squares from down here at the bottom all the way to the top. So these squares down here at the bottom are tiny. And then they get bigger and bigger and bigger and bigger until they get to the biggest stuff with the blue. Can you picture that in your mind what's happening? So what that tells me is this length right here, this is a side, this red side, from here to here is the length of the side. So how do I get a length here? What did we do when they were dy problems in area? Does anybody remember what we did to get the length, the r, or the length? We did what minus what? Right minus left. We're doing the same thing here. So we are going to do the integral from the bottom, which is 0, to the top, which is 1, because this y value right there, that y value is 0. This y value right there is 1. That's bottom to top. And then we're going to take the right, which is the green, which is this thing we just found right there in terms of y. So that's y to the 3rd minus this red line right there, which is 0. Now that right there is the length of your side. This thing right here, y to the 3rd minus 0 is the length of your side. And we're doing squares, so how do you get the area of a square? You take a side and, so we have to square this thing, dy. Now see this 0 to 1? That's all the squares from the bottom of 0 going all the way up to 1. And then these are all the squares. So when I take a square times this dy part, which is how big they are, that's going to be a volume. That makes it three-dimensional. This is two-dimensional. This part's 3. When you multiply that in there, that's why it's a volume. Well, I'm going to get rid of this because I don't want that, because then you're going to minus zeros itself. And then when I take this and square it, I believe I have the integral of 0 to 1 of y to the 2/3 power dy. So now I can integrate. So I'm going to add 1 to 2/3. 3/3 and 2/3 give me 5/3. And I can put that over 5/3, but I got to flip that upside down, so it's going to be 3/5 in front. And we are doing this integration from 0 to 1. As my lower bound is 0, my upper bound is 1. My bottom interval 0, my upper interval, my top interval 1. So I'm going to plug in 1 to the 5/3 minus 0 to the 5/3. I hope you know 1 to any power is 1. 0 to any power is 0. So this whole thing should end up being 3/5 as the volume of that, all those little squares. Okay, I will come around spread. I will see you guys